Now we turn to the question of what happens when an exponent is involved with another exponent, or in other words, powers. So consider our first example here, 2 to the 5th raised to the 4th power. So this is again a number problem. So we can work this out by working out 2 to the 5th. 2 to the 5th is 32. And then if we turn around and do 32 raised to the 4th power, we'll get 1,048,576. 1,048,576. That's one way to work this problem out with the numbers, because we can actually do 2 to the 5th. The other way is to realize that 2 to the 5th raised to the 4th is actually 2 to the 5th times itself 4 times. That's the definition of raising something to the 4th power. And then we can invoke our properties of exponents. We're multiplying, so we add the exponents, 5, 5, 5, and 5. 5 4 times is just 2 to the 20th, which is equal to 1,048,576, if you were to put that in and work that out. Now, just a little bit about that number. It's kind of a little tangent here. That 2 to the 20th, you may have talked about, heard about bytes and kilobytes and megabytes and gigabytes and all that kind of stuff. And you may have probably bought a hard drive or something for your computer, or your computer came with a certain hard drive, and then you looked up how much storage space your computer had. It was actually smaller. And the reason that happens is because when the manufacturer says your hard drive has 500 gigabytes on it, it's actually saying that you have 5 billion bytes. But when the computer reads memory, it's reading it in terms of groups of 2 to the 10th. So 1 kilobyte is 2 to the 10th, 1,024 bytes. And 1 megabyte is 2 to the 20th, or 1,048,576 bytes. Whereas the hard drive manufacturers, they say 500 megabytes, they mean 500 million instead of this extra amount. So that's just a little oddball thing that came up in this example here. I just wanted to point out. Let's continue now back to our actual problem here, which is dealing with stuff raised to an exponent. So here I have an h to the 6th. Unlike 2 to the 5th, I can't work it out because I don't know what h is. But just like we did up above, I can write that out as h to the 6th times h to the 6th times h to the 6th 3 times. And then using my properties of exponents, I'm multiplying, so I can add 6, 6, and 6, or 6 3 times, and I get h to the 18th power. H to the 18th power. Let's consider another example, one where I would not really want to write it out. I don't know about you, but I don't want to write out I to the 5th 12 times. But understanding what happened in the last two examples here, we can see that if I did have that written out, I to the 5th 12 times, I'd be adding 5 plus itself 12 times, or in other words, doing 5 times 12. And of course 5 times 12 is 60. And so there's our rule for powers. If we have something with a power raised to another power, then we're going to multiply our exponents. We're going to multiply our exponents.